Salam sejahtera. So thank you for joining our class today. So I already record our class for today. So later you will refer to the video again and again for you to understand. Okay. So I hope that you can see my screen. Okay. And then another thing is for today's class, I will explain to you how to design a continuous two-way slab, and also explaining our assignment for this subject. Okay, so for this week I will not give any task or tutorial, so but if you would like to have a question, you may come and DM me. Okay, then I will provide a tutorial question. Okay, so for today class we'll continue on reinforced concrete slab design for continuous two-way slab. Don't forget to fill up your attendance at the end of this class, okay? Okay, all of you can hear my voice, eh?
Yes, sir.
Okay, good.
Yes, sir.
Okay. So for today class, from the previous lecture, I do already explain you how to determine the slab is a two-way slab. So in my case here, so I have this structure layout plan that is combination of two types of slab, which is a one-way slab and also two-way slab here. Okay, so all the slab here is considered as a continuous slab because it is connected between each other. Okay, so for this slab we will consider as a continuous one-way slab, and then for this slab we will design as a two-way continuous slab. Okay, so in another thing is you would like to know, what you have to know is when you know this structure layout plan is actually a two-way slab, then you have to identify which cases belong to that slab. Okay, I do already told you previously we have 9 cases for continuous two-way slab. Okay, so you have to choose the correct slab. Okay, so here I'm going to design slab 2 to 3 AB2, which is 2 to 3 AB2, which is Lx is equal to 3.35 meter, Ly equal to 2.75 meter. Here are the data given. So the diameter bar is 10 mm is given in the question. So if it is not given, as usual, you have to assume the diameter bar is equal to 10 millimeter. Okay, the exposure class is XC1 is already given, but if it is not given, you have to check based on the exposure class condition or in table 3.1 in your design appendix. Okay, table 4.1. Okay, so you have to refer to that table, and then you have to refer the location of the project, where is the location, then you determine your own exposure condition. Next is the variable action. So if the variable action is not given, you have to refer to your Eurocode in the Eurocode 1, okay, so that you can know what is the variable action based on the types of building, either it is a residential, houses, apartment, okay, school, auditorium, and so on. Okay. And then another thing is, I do receive a question before this, is the load is not given, either we have to calculate it by own or not. No. The only load that we have to calculate by our own is a slab sulfate. The other types of load is not given. Okay, if it is not given, we have to, no need for us to calculate. For example, the finishes is not given, shielding and services is not given in the question. Therefore, we no need for us to calculate. This is for the purpose of examination and also test. But in the real situation, we have to identify by our own, okay, what are the elements that will contribute on top of the slab, the permanent action and also variable action. So I hope that you understand on the information given to determine design specification. Okay, because in your assignment, you have to determine your own design specification, which is I will explain it later. Okay, the first one is we have to check Ly over Lx ratio. So here, Ly over Lx ratio is equal to 1.17 is less than 2, which is two-way slab. Okay, and then due to the fire resistance, we have to refer, in order to calculate the nominal cover, we have to check due to the fire resistance, the bond requirement, and also the exposure condition. Okay, so we check one by one. Due to the fire resistance is equal to C minimum equal to alpha minus diameter bar over 2. How are we going to determine the value for alpha? So value alpha is referred to table 5.8 in your appendix. Okay. Here is your table 5.8 in your appendix, specifically for slab. Okay, here. So from this table 5.8, okay, we know that our Ly over Lx is equal to 1.17, which is less than 1.5. Therefore, our REI is 60, which means our our alpha value is equal to 10 millimeter. Okay. And then we proceed with the next step. Okay. So we continue due to the bond requirement as usual refer to table 4.2 equal to diameter of bar 10 millimeter. And then due to the exposure condition, C minimum durability by referring the table, and then you get the 10 millimeter, and then the C nominal by comparing these three value because it is same. Therefore, the C minimum is equal to 10 millimeter. The answer is 20 millimeter. Next is a design action. Design action is same what we have done before. Okay, firstly, we have to calculate the permanent action due to the slab self-weight. So our slab self-weight is equal to 25 times with the thickness 0.125 0.125 meter. So what we have to do when the slab thickness is not given in the question, we have to calculate by our own by determine the preliminary sizing by using two methods. The first one is due to the fire resistance. The second one is due to the span over depth ratio. During my lecture, if you have any question, you may interrupt and ask the question, okay? Okay. On the finishes, okay, we take from the previous value given in the design specification, and then the shielding and services, we total up here 3.675 kilonewton per meter square. The variable action is 2.5 kilonewton per meter square. Therefore, the design action N equal to 1.35 GK plus 1.5 QK. The answer is 8.71 kilonewton per meter square. As usual, for slab, we have to design per meter length. Therefore, the N value is equal to 8.71 kilonewton per meter square times 1 meter. Therefore, the answer is 8.71 kilonewton per meter. So it's already in uniformly distributed load. Okay, before I continue on the shear force and also bending moment, did you have any question, class? So if you don't have any question, I will proceed. Okay.
Sir.
Ya.
Saya nak tanya pasal yang table 5.8 tu.
Okay.
Apa maksud star tu?
Okay. Okay, here a star ni maksudnya normally the cover required by the Eurocode 19921 will control. Maksudnya if there is a specific requirement by the national annex, because some country have their own specification. So we may refer to the national annex sometimes. Okay, they have their own study. They are the specific on dia punya minimum thickness of the thickness of the sea. So in our case here, we just use this value lah. Okay. So normally it is same. Nothing different. Okay. So maksudnya dia bila kita tengok Eurocode 1992-1-1 ini dia adalah on a reinforced concrete design. Okay, so maksudnya this table, because okay, this table is actually adopted from British standard. Okay, so means that we apply the same table in Eurocode. Okay, so that's why it states here that normally the cover required by Eurocode 1992-1-1 will control. So if it is possible to have a new minimum requirement. So in a previous lecture note, I do already share with you the minimum requirement of the nominal cover. Okay, si minimum dia. Okay, yang ada table daripada National Annex. Okay, so that value will control this value. Okay, because that control is referred to Eurocode. Okay, so I hope that you understand. So if you have any question, you may ask again. Okay, here ada shear force and also bending moment. Okay, the first one we have to draw the shear force. In order for us to draw the shear force, okay, the formula we have to refer in our appendix here. Refer to this table. Okay, this table 3.14 is a bending moment coefficient for rectangular panels supported on four-sided with provision for torsion at corner. Here is the formula for MSX equal to beta SX and LX square. For MSY is beta SY and LX square. So the value here, okay, inside this table, here is your beta SX. Here is your beta SY. Here for the short span. Here for the long span. Okay. I will continue after this. Okay. Here for the shear force. Okay. For the shear force. Okay. VSY is equal to beta VX and LX. Okay. Untuk VSX is beta VX and LX. Okay, here is a table 3.15 shear force coefficient for uniformly loaded rectangular panels supported on four sides with provision for torsion at corner. So this value here is a value for beta VF for the short span. Here is beta VY for the long span. Okay, we have all 9 cases here. So you have to choose the right cases. Okay, so based on our case here, okay, because this slab, okay, is located, okay, at the corner here, therefore this slab is considered as two adjacent edge discontinuous. Okay, two adjacent edge, maksudnya dua sisi bertentang, dua sisi yang berbucu di sini, okay, bertembung di bucu ini tidak bersambung. Okay, so kita tengok dia adalah case which cases. Okay, two adjacent edge discontinuous. For the shear force is here. Case number 1, 2, 3, 4. Two adjacent edge discontinuous. Okay, same goes to bending moment is also case number 4. 1, 2, 3, 4. Two adjacent edge discontinuous. How we going to determine the value for this one? Okay, value for, okay, so macam mana kita nak tentukan value for beta VX1 and beta VX2? Okay, so please take note here, please do take note here. Okay, so from this, okay, table, okay, for the shear force here, okay, untuk discontinuous edge, okay, discontinuous edge is beta VX2, okay, and also beta VY2. For continuous edge, okay, is beta VX1 and beta VY1. Okay, I repeat it again. Okay, for discontinuous edge, the value inside the table here is beta VX1 and beta Vx2 and also beta Vy2. Okay, for continuous age, is become beta Vx1 and also beta Vy1. Okay, so same goes, okay, to this table for the bending moment. Okay, so here, okay, bending moment they use a positive and negative value. So kita dah belajar before this. Positive value is always at the midspan and negative value is always at support. So no need for you to confuse. Okay, so positive moment is always at midspan, negative moment is always at support. Okay, so means that ini akan jadi MS@1, okay, ataupun akan jadi beta S@1, okay, yang positif. Ini akan jadi beta S@2, okay, yang negatif. So here will become beta SY1, here become beta SY2. Okay, so in my case here is two adjacent edge discontinuous. So we go through on the bending shear force first. Okay, so here we have a look here, two adjacent edge discontinuous here. So we will have four coefficient here. 1, 2, 3, 4. Means that we have four value of shear force. Okay, at discontinuous edge we have value, at continuous edge we also have a value for both for both edge, short edge and also long edge. Okay, okay, how to determine this value? Okay, for example, our case here is 1.17. 1.17 is between 1.11 and also 1.12. In order for you to get the value, okay, for Ly over Lx is equal to 1.17, okay, for the continuous edge, which is beta Vx1, okay, is in between 0.44 and 0.47, you have to do an interpolation. Okay, so basic interpolation. Okay, so you have to do for both value, for continuous edge and also discontinuous edge. For long span, no need, because we just take the value, so no need for to do the interpolation. Okay, so the process is also same for the bending moment. We also have to do the interpolation between 1.12 and 1.2, which is for these cases number 4. Okay, so here in between 0.056 and 0.063 will appear or will occur value for beta Sx2. Between 0.042 and 0.047 will appear value for beta Sx1. Okay, and then here for the long span, no need to interpolate, we just take this value. So that's why from this interpolation, okay, I can get all those coefficient value for the beta Vx1, beta Vx2, beta Vy1, beta Vy2, beta Sx1, beta Sx2, beta Sy1, and also beta Sy2. So you calculate all those value and then you will get answer here. You have to remember when it is a shear force, it's supposed to be in kilonewton, and for the bending moment in kilonewton meter. Okay, how to draw this shear force diagram and also bending moment diagram? Please be careful. Okay, for the short span, okay, for the short span, okay, the value of the shear force is value for Vsy. For the long span is a value for Vsx. Okay, so for example here, okay, so this is a continuous edge. Okay, this is considered as a continuous edge based on our diagram. Okay, here this continuous edge, here also this continuous edge. Okay, that's why, okay, at short span, at the continuous edge is become Vsy1. At this continuous edge is become Vsy2. Okay, for the long span, okay, at continuous edge become Vsx1. At the long edge ataupun discontinuous edge is become Vsx2. Okay. Okay, let's say, so if we have an interior panel, okay, so saya bagi satu example on interior panel. So I will draw for you one example. Okay, if we have interior panel like this, okay, so means that all of 4 edges is apa dia? Saya nak tahu for the short span and also long span. Anyone can answer? Kalau dia adalah interior panel. Please help me to answer. So maksudnya dekat sini, dekat dia punya edge ini adalah continuous ke discontinuous?
For edge continuous.
This.
Siapa yang jawab discontinuous? Interior panel. So what
Semua
is
continuous.
panel? What is interior panel?
Panel antara slab.
Okay, so means that all the slab is, all the edges is connected to
Another slab.
another slab. Okay, good. Okay. Okay, so it means that all those 4 edges is continuous. Okay, so how are we going to draw the shear force and also bending moment? Okay, so for the shear force, okay, so macam biasa kita divided into 4 edges. Okay. Okay, dia akan jadi macam ni. So all those 4 edges is a continuous. Okay, so we know that all those 4 edges continuous. So kita tengok so value daripada kita punya table 3.15. Okay, for the shear force. Okay, so interior panel is case 4 edges continuous. Okay, so when we have a look here, okay, there is only one value here. Okay, so one value for short span, one value for long span, and the value is only for continuous edge. There is no value or coefficient for discontinuous. So therefore here, okay, we back here. So okay, so all the value here will be like this. Okay, for the long span here, dia akan jadi VS at 1. Okay, here is also VS at 1. Okay. Here will be, kat sini akan jadi apa? Dia akan jadi apa?
VSY1.
Okay, VSY1. And then the other side is also
Y1.
VSY1. Okay, because all of these 4 edges is continuous. How about the bending moment diagram? Okay, so I copy this. Okay, so we have a look on our previous example first. Okay, on the bending moment diagram here. So we also refer to the table 3.14 here. Okay, so from this table 3.14, two adjacent edge, kita tengok at all those 4 coefficient, they got the value. So means that we will have 4 moments. Okay, so that's why here in my example, so we will have 4 moment. Okay, so the moment for MS at 1, okay, for the short span, yang ini tak ada berubah macam shear force yang X is still a short span, Y is still a long span, okay, for bending moment. So for the MS at 1 is at the midspan. MS at 2 at the support. Okay, but why there is only a value at this support? Tak ada dekat support sini. Kenapa tak ada dekat support sini? So anyone can explain to me? Answer my question.
Sebab yang tu discontinuous.
Yes, correct. So when it is discontinuous, the value of the moment here is equal to 0.
Oh,
Okay. Okay, ini adalah MSY untuk long span, MSY okay for the mid span untuk long span, MSY2 for the support at the long span. Okay, so let's say okay we have this example. Okay, so how to draw our bending moment here? Okay, so to draw the bending moment, because this is an interior, so ini wajib korang kena lukis kalau dalam test pun, because there is a mark. Kalau you tak tulis value dia pun, you tulis MS1, MS2 macam tu. Okay, so because all the edges is a continuous, so there is a value here. Okay, so there is a value here. So value here will be M SX1. Okay. Okay, here will be MSX2. Okay, so here will be also MSX2. Okay, here will be MSY2. Okay, and then another one is, here is your MSY1. Okay, so here will be your bending moment diagram. Okay, so you may try for the other example lah. Okay, so I hope that you understand how to draw this shear force and also bending moment. So from that, I will have this value. Okay, next on the design main reinforcement. On the design main reinforcement, the first one we have to calculate the effective depth. So on the effective depth, we have two effective depth. The first one is due to the short span dx, and another one is due to the long span dy. So for dx is equal to h minus c nominal minus 0.5 diameter bar. Okay, for dy is h minus c nominal minus 1.5 diameter bar. And then as usual, we have to calculate AS minimum and also AS maximum. Our B, don't forget, our B is 1000 millimeter. Then you calculate your AS maximum, then you provide the secondary bar as before, okay, which is I allow you to provide H8 minimum diameter for secondary bar. For the main bar, at least is 10 millimeter. Okay, and then when you have 4 moment here, means that you have to design 4 main reinforcement. Okay, you have to remember this. But in final exam or in exam question, so you have to read the question carefully. Either it asks you to calculate at all members, or they ask you to calculate, for example, design the main reinforcement at the short span only. Okay, design the main reinforcement at the maximum mid span. Maksudnya, you have to calculate for short span and also long span at mid span sahaja. At the support, no need to calculate. Okay, it depends on the question. So we calculate one by one. For the short span, you have to remember the difference is only D here. For the short span, the D here that you have to use is DX. Okay, and then you provide minimum is H10 300. The diameter is 10 millimeter, and check it should between. Okay, the answer should be between minimum and also maximum value. And then for the short span support MSX2, so you still use DX as your D here. Okay, and then you provide, and then repeat for the long span, and then the D here that you have to use is DY. Okay, DY here. And then here you provide, and then you calculate for the long span, okay, MSY2, and then the D here you use DY, and then you provide H10 300 center to center. So that is for the main reinforcement. Next, for the shear reinforcement. Okay, for the shear reinforcement, so we have to check, okay, as usual, VRDC over, you have to calculate the VRDC and also V minimum, and then you have to compare which value that you have to use in order for you to compare with VED. In my case here, okay, VED is less than V minimum. The D value here that you have to use is your DX, okay, DX. Okay, so for the deflection check, okay, for the deflection check, as usual, we have to check L over D basic, L over D allowable, and L over D actual. Okay, so we have to check the condition rho and also rho naught. So because it is rho naught is more than rho, therefore we use equation 7.168. Then the answer here, L over D basic, is 255.33. So why I use K is 1.3. So the K is referred to table 7.4. So if you refer to table 7.4, okay, I don't have a soft copy here for the table 7.4. Okay, so because this is a two-way slab, so end span of continuous beam or one-way continuous slab, or two-way, okay, spanning slab continuous over one long side. So means that the K is equal to 1.3. So based on table 7.4n, okay, and then I've got the answer here 1262, and then the L over the actual D here is DX, and then the deflection check is pass. Okay, before I'll continue on the cracking check, you got any question, class? Ada soalan? Ada nak tanya?
Sir,
Ya.
boleh ulang balik tak yang continuous H tu BVX 1 ke 2?
Sekejap ya. Continuous two-way slab design. Yang mana tadi?
Kalau continuous H, kita consider BVX 1 ke atau 2?
Continuous. Satu. Ni, shear force ni, okay. Continuous H is BVX1. 1. Discontinuous H is beta VX2. Bukan B, beta. Boleh eh? Okay.
Okay, sir.
Okay. We continue on cracking check. Okay, so we done on all of these. So cracking check is same as what we have done before. We have to check 3 conditions. The first one is the slab thickness should be less than 200 millimeter, and then the main bar, okay, should be less than 400. 3H is less than 400. your provided here is refer to your actual main reinforcement, and then the second rebar should be less than 450. Okay, so ni supposed to be less saya typo ni. Okay, less than 450. So all acceptable, the cracking value. Here are the detailing. The detailing here quite complicated, so you have to know, okay, which one is the second rebar, which one is the primary bar. Okay, so which one as the top, which one at the bottom. So normally if it is at the mid span, okay, at the mid span, normally for the short span it will be at the bottom. Okay, for the long span it at the top. Okay, for the support it will be vice versa lah. Okay, because the moment behavior is different. Okay, sagging moment and also hogging moment. So you may study it and then you may try to understand. Okay, any other question before I'll continue explaining on our assignment?
No, sir.
Okay, so on our assignment here, saya buka folder lah. Okay, on our assignment here, here is your assignment. Okay, so okay, so student are required to form a design team. So sekejap lagi in your group WhatsApp, please write down, okay, of your group. Means that, for example, salah seorang contohnya nama Liza, okay, design team 1, okay, berapa orang, okay. So nanti I'll give you an example from another group, okay, so that I will know all of you already have a group. Nanti I will explain it again. So from the same class of contohnya kalau E1 itulah, okay, because of it easier for me to fill up your marks and also attendance and so on, okay. So given is the structural layout plan for cadangan membina dan menyiapkan sebuah masjid Taman Seri Bayu daerah Kuala Muda Sungai Petani Kedah. So means that you know this is daerah Kuala Muda Sungai Petani Kedah. So you have to determine your own exposure class. Okay, so identify and justify the design specification of the reinforced concrete structure element here. So all of this you have to do in a table for the design specification. So for example, okay, you boleh buat dalam table. Okay, you boleh insert in your table. Okay, numbers, okay, specification. Okay, and then value. Okay, and then I need a references where you get the value. Okay, for example, here is your number 1 is your exposure class. Value is X, for example, XC2, okay, from table 4.1, okay, nearby, okay, contohnya, okay, XC1 is dry and corrosion concrete inside building with low concrete inside building with low air humidity, contoh, okay, and then you have to explain lah dekat situ, okay, daripada mana you dapat, so this value semua. Okay, you may separate between a slab and also beam, okay, if you would like to have both lah, okay, so if not you can just write down here lah contohnya, okay, because all the value you will use for all the design. Okay, so because we will have two, which is beam and also slab. Okay, so if you would like to separate the design specification, it's also can. Okay, so it's up to you. So this is just an example, and then you may complete it lah. So kalau you would like to type or handwriting, is up to you guys. Okay, so if you would like to type, you may follow. Okay, who's come from the diploma, you already see your design sheet before this. Okay, so you boleh follow your design sheet. Okay, so if you do it in Excel, please make sure when you would like to save in PDF, okay, please make sure the the box tu only nampak dia punya boundary saja macam ni. Okay, like this. Okay, jangan nampak semua kotak dalam ni, saya tak nak. Okay, so make it properly lah. Okay, so we go through. Okay, so you have to determine all these design specification by your own, and then instruction number 2 is choose one two-way slab and also one-way slab. Okay, so from the structure layout plan given, table 1 shows the types of slab finishes. What are the types of slab finishes? So let's say if you already choose a design team 1, okay, so means that your slab finishes is marble, thickness is 10 millimeter. And then for the beam, you need also to choose design team 1, okay, BM1 for simply supported beam, continuous beam is BM14, brick wall full height is 3 meter. And then here are the instruction for, okay, brick wall layout. So it means that the location of the brick wall, either that beam is receive a load from brick wall or not. And then you have to propose full reinforced concrete design for ultimate limit state design and serviceability limit state design until the detailing. Okay, and then you have, as a submission, you have to save your design calculation in PDF format and compile the work as a design team. Please submit your design work in Google Classroom or Microsoft Teams. So my class is in Microsoft Teams lah. Okay, only a group leader is required to submit and fill up the declaration submission form. So I will attach the declaration form. Okay, because this is a requirement by HAA. Okay, submission is on 15 May 2020. Okay. Before that, I will show to you the structure layout plan. So here are the given structure layout plan. Okay, so in this structure layout plan is already stated the beam that you have to design. Okay, beam 1, 2, 3, 4, 5, 6, 7 and 12. Okay, you boleh pilih your slab. Okay, which one is a two-way slab, which one is the one-way slab. Okay, for example, this one is become a one-way slab lah. Okay, here it will be your two-way slab. Okay, so mana-mana you boleh pilih. Okay, so I hope that you understand that. Okay, so on the assessment here, so this assignment will contribute 30%. Okay, so you will have 4 elements that you have to design, will contribute 25 marks each. Total is 100 marks, and then the weightage is 30% here. So try to get as much as you can. Okay, okay, so here are the rubric of the marks. Okay, so means that ada 4 elements, so we will fill up the 4 rubric lah. Okay, so 4 element lah, so maksudnya setiap satu ni akan contribute 25 mark, 25 mark, 25 mark. Total up baru saya akan weightagekan kepada 30%. So for assignment task 1 and also quizzes, okay, so we'll reveal the mark 40%. For another 60% assignment task 2 and also test, okay, we will not reveal the marks. Okay, so I think here I do already post your assignment. Okay, you may have a look lah on your assignment. Okay, so what are the content of the assignment? Okay, and then don't forget to fill up the class attendance. Nanti here I will add another information regarding the submission. Okay, so for next week class, so I will inform you later. Either we will have a class or we will I will share the video. So I do already have a class with group 6E this morning regarding simply supported two-way slab. So you may refer to that video for your self-learning for two-way slab. And then we have another one element that we are still not covered yet, which is continuous one-way slab. Then I will prepare the video and then I will share the video to you, okay, as usual in my YouTube channel, so that you can have a self-study. If you have any question, you may ask, and as usual lah, you may WhatsApp me or DM me or email to me or whatever platform lah. Okay, so I think that is my lecture for today. So you have any question, class?
Sir,
Okay.
sir, kalau nak tanya pasal task tu, sir.
Okay, boleh?
Kan kalau kita kira kan, lepas tu kita punya calculation tu fail. Kita kena redo ke macam mana, sir?
Yes, for the assignment, you have to make sure that your design is pass. Okay, for test tak apa. For assignment, because this is become your mini project, you have to do a real situation of the design. So means that each of the things, each of the parameter, design reinforcement, check for shear, deflection, crack is passed. So that your detailing will be correct lah. Okay. Any other question? And then another thing I would like to remind is for the whole team or group members or design team, so please make sure your parameter is same Jangan guna lain-lain. So contohnya, for example, the slab thickness. So if contohnya for Shazwan use 110, Syafuat pun have to use 110. Jangan seorang use 110, seorang use 125. Except you have justification. Because our slab is in the same floor. Okay, kalau at a different floor, there is possibility to have a different slab thickness. Okay, so between all of you, you have to compare lah. So which one is the contohnya antara Shazwan and Syafuat, which thickness yang lebih tebal. So we have to use the maximum one lah. Okay, any other question? Ada soalan lain? Any other question, class?
So far tak ada, sir.
Okay, so if you don't have any class, you don't have any question, so that is end of our class. Okay, you may dismiss from this class and don't forget to fill up your attendance. Okay, any other information regarding our class? Okay, I hope that
Sir.
can contact it. Okay, apa?
Yang nak tanya pasal kan pilih slab finishes semua tu kan, jenis-jenis thickness berbeza kan. So satu group satu design team ke ataupun dia tak apa, macam contoh kalau group saya dengan group lain pilih nombor 2 tapi kita orang data lain, boleh sir?
No, you have to use a different design team. Okay, so means that in my class I have a 33 student, so means that I have at least maximum 7 lah. Okay, 7 times 5 is 35. Okay, so that's why I will nanti dalam WhatsApp saya akan minta untuk korang fill up the things and then inform me the group member. Okay, so that it will not redundant. Then which design team are you? Okay, any other question?
Okay sir, faham sir, thank you.
Okay, if not, that's it for our class. Okay, thank you. Assalamualaikum.
Salam sir.
Terima kasih, sir.
Salam, sir.
Waalaikumsalam, sir. Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.
you, sir.
Okay.